I'm here with Josh Willis, and Josh is an oceanographer at NASA's Jet Propulsion Labs. So tell us about the work that you do at JPL. What's your research?
Well, I study sea level rise and global warming using data from NASA satellites like the Jason series of satellites, which measure global sea level rise from space. And they can do this with an accuracy such that we can see the background 3 millimeter per year rate of global rise that's caused by global warming.
I get the strong sense when you put it like that that you're not making it up, Josh.
I'm not making it up.
And how does that fit into JPL's sort of broader climate research?
Well, there's a lot of research that goes on here at JPL that pertains to the climate, and most of it revolves around different satellites. The Jason satellites measure sea level, but equally important are the GRACE satellites. These actually weigh entire continents and the ocean. So using GRACE, we can essentially weigh the continent of Greenland, we can weigh the continent of Antarctica, and what we see is that they're losing weight. They're losing mass as the ice melts and runs off into the oceans. So these are powerful tools for explaining the causes of global sea level rise and watching it occur, which is really important because we expect global sea level rise in the next 100 years to accelerate dramatically. We have 3 millimeters per year today, but in a year or two we might have 6 or even 9 millimeters per year of global sea level rise. And it would be a very different planet, a very different adjustment for us with those kinds of rates.
And I guess it's not just the gradual increase, it's the combination of the major weather events on top of those gradual.
That's absolutely right. If you live by the coast, then you don't just care about what global sea level rise is doing. You care about whether your coast is going up or down, whether there's a high tide or low tide, whether there's a storm off of your coast driving the water inland and raising sea level. But global sea level rise happens on top of all those things. And so as we look into the future, the very high sea levels that do so much damage will come more and more frequently. And this is where the big impact from global warming and sea level rise will be for most developed nations.
Okay, one last question. I think I'm a little bit nutty, but I think about it this way. I once heard that there was a 35-year delay, broadly, between atmospheric warming and ocean warming because of the inertia factors in the oceans.
Right. Well, the oceans really set the time scale for how the planet heats up, because 80 to 90% of the extra heat that we trap from greenhouse gases winds up warming the oceans. So this is where really all the heat, almost all of the heat from global warming is going. And it's the oceans that warm our atmosphere. So if we had no oceans, global warming would have already happened. We would already be several degrees warmer than we are today. So the oceans really allow a delay in the reaction of the planet to our warming climate, to our addition of greenhouse gases to the atmosphere.
Okay. Thank you very much.
Thank you so much. It was really nice talking to you.